Okay, so we're going to start, this whole chapter is on probability and predictions. So today we're going to start by looking at probability and simple events. And our goal is to find the probability of a simple event. So we don't know necessarily what all those words mean right now. We're going to start though with this intro. So a cheesecake has 4 equal slices of each type as shown. So you see we have 4 different kinds of cheesecake. We have original, raspberry, chocolate, and turtle. Right here the original has 4 slices. Right, the raspberry has 4 slices. The chocolate has 4 slices. And then the turtle we can't see right here, but it also has 4 slices. Because it tells us each one has 4 equal slices. So we want to know what fraction of the cheesecake is chocolate, and then write that in simplest form. So right now on your own, if I ask you what fraction of the cheesecake is chocolate, write down what you would write as your answer. Okay, so what did we get? What fraction is chocolate?
4 out of 16.
4 out of 16? What'd you put, Grant?
5%.
Okay, what'd you put?
20.
And how'd you get 20?
Because there's 4 sections,
Mm-hmm.
and there's 4 in each slice. So I have no idea.
You don't know how you got 20%? You can make it a percent, but 20% would not be the correct percent. Yes, 25% would be the correct percentage if you turned it into a percent. What did you say, 4 out of 16? Anybody say anything different? Well, I still hadn't heard the right answer.
That's not it.
No. Hmm? 25% is the way we can say it. But I want it as a fraction. It says what fraction. It doesn't say what percent. Yeah. How do you get 1/4? No. There are 4 chocolate pieces out of the 16 total pieces. And that reduces. They're both divisible by 4. So that should be 1/4. Does everybody understand that? You're not going to, here's the deal. This is not a lesson that you can just copy what I do. You're going to have to think. So you got to understand what you're thinking about. Does everybody see where that comes from?
Yeah, because there's 1 chocolate section of all 4 of them.
No, because there are 4 chocolate pieces out of 16 total.
So you just simplify.
4 out of 16 simplifies. They are both divisible by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. Suppose your friend gives you the first piece of cheesecake without asking you which type you prefer. Are your chances of getting original the same as getting raspberry?
Yes.
Yes.
They would be. Why?
Because there's the same amount of slices each, division.
Because there are 4 raspberry pieces and there are 4 original pieces, you have the same chance of getting either one, which would be 1 out of 4 or 25% for every one of them. Is any one of the possible results of an action. So basically an outcome is what happens. So if you flip a coin, how many outcomes are there?
2.
2. You could get heads, you could get tails. Those are called the outcomes. Next is a simple event. A simple event is something that has an outcome or a collection of outcomes. So, for instance, a simple event, if we go back to our coin, that would be flipping a coin. That is the event. When you flip a coin, it has one outcome or a collection of outcomes. Can anybody think of something else that would be a simple event that has to do with probability?
Rock, paper, scissors.
Okay, rock, paper, scissors would be a simple event. Anything else? Okay, do y'all know what we normally, what kind of things do we normally use when we're dealing with probability? I've already told you one of them. A coin flip is one that we'll use a lot.
Oh, where you put your thing.
Mickey Mouse Clubhouse.
That's not.
No, you're thinking like when you pick somebody,
Yeah.
okay? That is probability, so that does have a part of it. I was thinking more along the lines of like the way we normally ask probability questions. Think about your Global Scholar test. Anytime you've had a probability question, what kind of questions have they been?
Like, if a girl doesn't one thing,
Y'all don't think you know what I'm asking? No. But normally when we ask probability questions, we're flipping a coin. We are rolling dice. We are spinning a spinner. Did you not see any questions like that in any of your Global Scholar?
No.
yes, the spinner one. The top, that spin the top. Yes.
Okay, those are the kind of problems that we can expect to see a lot of. And when I roll a dice, that's a simple event. When I spin a spinner, you know what I'm talking about when I say spin a spinner? Like one of those that's got it's rotating around, it's going to land on a different color or a different number. When I spin the spinner, that's a simple event. A simple event has one outcome. For example, getting a piece of chocolate cheesecake would be a simple event. So receiving a piece of cheesecake would be the event. The chance of that event happening is called probability. So that's our last vocabulary word. Probability is the chance that the event happened. So probability, you can see inside of it, it has the word probable. Right? How probable is something to happen, which just means how likely or the chance that the event occurs. What's the probability of, when I flip a coin, getting heads? Okay? How many favorable outcomes are there? Do y'all know what favorable outcomes means?
More to get.
What we want to happen. So if I'm flipping a coin and I called heads, what I want to happen is to get heads. That's what goes up top. So if I flip a coin, how many ways are there to make heads? One. There's only one side that's heads. How many possible outcomes are there when I flip a coin?
2.
2, heads or tails. So the probability of flipping heads is 1/2, or 50%. If I ask you for the probability of rolling a 4, so say I've got dice. So how many sides does a dice have? 6. How many of those sides have 4 on it? 1. So what's the number of favorable outcomes? 1. Rolling a 4, there's only one way to do it. How many possible outcomes are there? 6. So the probability of rolling a 4 on a dice is 1 out of 6. Okay, let me ask you what's a little trickier. Let's go with dice again. What's the probability that I roll an even number?
Like 3.
Yeah.
So what are the three ways I could roll an even number? 2, 4, and 6 are all even. So the number of favorable outcomes would be 3 that are even out of the possible outcomes that's still 6. So it would be 3 out of 6, which will reduce to 1 over 2, a half. It's 50-50 if you get an even or an odd number on rolling a dice. So our book does not call them dice. They'll call them number cubes a lot of the time. So it says use a number cube to find the probability of each event. Write it as a fraction in simplest form. Then they want you to convert it to a decimal and a percent. So when we write these as a fraction is one way to represent the answer. But we could also make it a decimal or a percent. Y'all have already turned them into percentages, right, as your answer. All right, so the only thing you haven't done is a decimal. So how do we turn a fraction into a decimal? We just do the division. So in the last example, we had 1 over 6. In my calculator, I would just put 1 divided by 6. If you put that in, it'll turn it into a decimal for you. And then how do we turn a decimal into a percent? 2 places to the right. Just what we just got done doing. So right here, you try these 3, because I kind of led you into it. The example question was the probability of an even number, and I just talked about that. So there's no point in talking about it again. So you try these 3. What's the probability of getting an odd number, the probability of getting 5 or 6, and then the probability of getting a prime number? Odd number. First, as a fraction, what did you get?
I don't know. I don't get it.
Okay, so when we're finding the probability of an odd number, it's a fraction. It's the number of favorable outcomes over the number of total outcomes. So I always normally start down here. Total outcomes. So I'm rolling a dice. How many different outcomes are there? If I roll a dice, what all could I get? You know what a dice is? You know how many sides it has? 6.
Well, let's count those.
So what all different numbers could I roll if I roll a dice? 6 different ones. 1, 2, 3, 4, 5, or 6. So the number of possible outcomes is 6. How many of them are odd? So from 1 to 6, how many numbers are odd? 1, 3, and 5 are all odd. So you have 3 odd numbers out of the 6 total numbers. So the probability of getting odd, you should have 3 over 6. 3 over 6 reduces to 1/2 as a fraction. Now we need to make this into a decimal. So we would divide. 1 divided by 2 in our calculator. Everybody put it in. 1 divided by 2 is 0.5. And then to make a decimal into a percentage, we move the decimal 2 places to the right, which would give me 50%. So the probability of getting an even number was 1 out of 2. Well, the probability of getting an odd number is also 1 out of 2. Okay, B part. It asks for the probability of getting a 5 or a 6. So everybody try that one. You thought it was asking what?
Which one?
No, this is a whole different question. So remember, it's the probability of some event. So this is the probability of 5 or 6 happening. So think about how many total possible outcomes. How many of them are favorable, which means what we want to happen. And then go from there. So we should get 2 out of 6, which will reduce. 2 over 6 reduces to be 1/3, 1 over 3. Then we need to make this into a decimal. So in our calculator, we will do 1 divided by 3. 1 divided by 3 is 0.3 repeating.
So we do the second decimal place, right?
And then we move the decimal twice to make it into a percent. So that would be 33.3%, which we'll just abbreviate to be 33%. Yes, but this is the way you got to think about it. It's an event. So say that you're rolling dice against your buddy, and say you've got 2 friends, and you're trying to pick who's going to win. So everybody gets 2 numbers. So that way everybody's got an equal chance. So your buddy gets 1 and 2. Your other buddy gets 3 and 4. You get 5 and 6. So you want either 5 or 6 to happen. You just need one or the other. It doesn't matter which one. 5 or 6 will help you. So because it's just one event, what's the chances of getting 5 or 6? There's 2 ways you could get it out of the 6 possible. Does that help? And or are kind of confusing words, and you really don't get into that till you get up to upper level grade in math. But just know if we need 5 or 6, that just means you want one or the other. There's no way in one event to get 5 and 6. That would have to be 2 separate events. So when you see and, you're looking at 2 events. We're going to talk about that later, and we do compound events. But with or, that means in one event, you want one or the other to happen. Okay, and the last one, the probability of a prime number.
I have no idea.
What's a prime number?
Even
Number that can only be divided by one small factor.
the best, the number that you can get the most.
The biggest number, 2, 3, and 5.
No. So, a prime number is a number whose factors, you know what a factor is? It's a number whose factors are 1 and itself. So, for instance, if I pick the number 10, what are the factors of 10? 2 and 5, 1 and 10. Because 2 times 5 is 10, 1 times 10 is 10. Did I say it wrong? 2 times 5 is 10, 1 times 10 is 10. So that has 4 factors. So 10 is not prime. It's what we call composite, because it has more than just 1 and itself as factors. So like the number 17. What can multiply together to give you 17?
Nothing. So 1 and
1 and 17. But the order doesn't matter. Okay? So 1 times 17 is it. It's the only thing that multiplies to give me 17. So we would say 17 is prime. So from 1 to 6, you need to know what are the different prime numbers.
2, 3, 5, 7, 11.
Okay? From 1 to 6. Think about on the dice. So you're right, you're naming them. 2 is prime. 3 is prime. 5 is prime. 1 is the tricky case. Okay? 1 is not prime. 1 is not composite.
Oh, prime, where you can get numbers times 4, right?
What?
The prime number means you can have times.
A prime number means its only factors are 1 and itself. So like 4, its factors are 1 and 4, 2 times 2. So it has 3 factors, 1, 2, and 4.
So it's not prime?
So it's not prime. It's composite. The only prime even number is 2. Because after 2, 4, 6, 8, 10, 12, they all can be represented as 2 times something. So those are all composite. So there's only one even prime number, it's 2. Every other prime number is odd. And there's a bunch of them. There's as many numbers as you can count, that's how many prime numbers there are. So the probability of getting a prime number, so we're still rolling a dice. So how many possible outcomes are there?
3.
How many possible outcomes are there? 6. 1, 2, 3, 4, 5, and 6. How many of them are prime? 3 of them. The number 2, the number 3, and the number 5 are the only prime numbers from 1 to 6. So 3 over 6 reduces to be 1/2.
Decimal.
1/2 is 0.5, which if I move the decimal twice, gives me 50%. Okay, so let's do 1.
One's easy.
Pick a number 1 through 6.
It's 7.
It's 6. Pick a number 1 through 2.
It's 2.
It's 1.
I got it.
Okay, so the probability of M. So it's going to be a fraction, the number of favorable divided by the number of total.
Put the 8 on the bottom.
8 on bottom, there are 8 total possible outcomes.
And then there's only one M.
There's only one way to get an M. So it would be 1 out of 8. The probability of getting M is 1 out of 8.
I got it right.
Now we need to make that into a decimal and a percentage.
You divide
So divide. 1 divided by 8 is
0.125.
0.125. Move the decimal twice, and that gives me, I'm just going to put 12.5 because that one rounds nicely. You could round up to 13. It doesn't really tell us how it wants it. So I would, if you put 12, 12.5, or 13, I'd probably count them all right. Are there any questions there? Any questions? Are we ready to do 2, or do y'all need a second to work 2? Pick a number 1 through 6. It's 6.
I didn't.
Shh. Well, that's okay. We're going to work it out now. She's going to work it out now.
So you put 8 on the bottom.
There. Why?
Well, there's 8. There's 8 of them.
There are 8 possible outcomes. There are 8 different answers. Yes.
And 2 on the top because there's 2 chances.
We're looking for Q or R. So there's only one Q and one R. So that gives us the 2 possibilities that we're looking for. So that would be 2 out of 8. Will that reduce as a fraction?
To 0.25.
Okay, it's a decimal. I agree. But will it reduce as a fraction?
Yes.
So what is 2 over 8 reduced to? You know how to do it in your calculator? You can hit 2, ABC button,
Oh, yeah. And then
8 equals
1 over 4.
1 over 4. So it's 1 over 4, which is 0.25, and then make that into a percentage. 25%. 2 places to the right. Okay, then the last one, the probability of getting a vowel. Pick a number, 1 through 6. It's 4. Pick a number, 1 through 2. It's 2.
I wouldn't want to know what a vowel is. Okay.
So how many possible outcomes are there?
1.
Still 8. And how many of them are favorable? 1. Which one is favorable? O. Your vowels are A, E, I, O, and U. Yes, Y can make a vowel sound.
Oh.
Oh, yeah. O's and O's.
So this is 1 out of 8. Now let's make that into a decimal. 0.125. And then as a percentage, 12.5 or 13%. Okay, try these 6. So read it. It says a set of 20 cards is numbered 1, 2, 3, ... which means and so on, 20. Suppose you pick a card at random without looking. Find the probability of each event. Write it as a fraction in simplest form, a decimal, and a percent.